if you're going through and you have to evaluate the function without using calculators, because this is kind of what the whole idea of being able to do this, excuse me, works out, is that this is the main importance, like I was saying, about how you find reference angles. So if you're able to figure out where your reference angles are, then it's a quick draw of which right triangle you're using to be able to evaluate the tree. Now, I know that it seems a little bit different than how we've done a lot of the stuff before, but this is, if anything, I think I said this on the video, if anything, that this is probably the most visual stuff we do all year, because it is so easy to draw what exactly you're looking at, and knowing how all of your right triangles and your special right triangles work, which you do, how easy it is to put it all together. So for example, if I'm looking at to try to find what is the cosine of negative 4 pi over 3, means first of all I got to figure out where is negative 4 pi over 3. So it being negative 4 pi over 3, is that more or less than 1 full pi? More, well, I should say. Okay. More or less, yeah, absolute value-wise, but yeah, so we got to go past a pi, and we kind of come up how far off that axis? Pi over 3. So my reference angle here is going to be pi over 3. Now, which is 60. Very good. Now that's the idea. When you start looking at how these pi over 3s, pi over 6s, or pi over 4, the pi over 3s reference a 60-degree angle. The pi over 6s reference a 30-degree angle. And then obviously pi over 4 references a 45. Okay? So if I'm drawing this out, I know then that this is going to be a 60-degree angle. And what is always opposite your 60? The root 3. Now, is that vertical going to be positive or negative? It's positive. My adjacent is going to be how much? Negative 1, very good. And that's the idea. What you're doing here is you're placing your angle to figure out, well, what's the cosine at 60? The cosine would be negative 1/2. There's your answer. If you want, that's fine. That's fine. I will say that when we get to 14.4, you're working backwards. It's going to be easier to understand where to draw it first, as opposed to worrying with your absolute value. Okay? Trust me on that. I know, I'm a jerk. Okay? But but hopefully that wasn't too bad, was it? Once you spin it to win it, if you will. You guys missed me and my bad humor. I can only say these things so often to my children. They kind of look at me like. Then again, they're all sick. So let's see, negative 225. It's going to be a 45-degree reference angle into which quadrant? Which one is that? Top left, which is quadrant number? There's your 45, 1, negative 1, and root 2. So cosecant is the inverse of sine. Sine would be opposite over hypotenuse. Cosecant would be hypotenuse over opposite. So that would be much easier in this case. Nice when things are visual and things come together. Okay. Now, then you guys had what? What did I give you? Like a dozen of these out of the book? Is that about right? Yeah. Was there any in there that was bad?
No.
Oh, kind of the same problem, weren't they? And that's and that happens. And that's how I always ask you, like, what's going to happen if you don't get a special triangle? Then you're going to look at problems like this. Well, what's the sign of -10? I don't know. I have to press a button on the calculator. I don't want to use calculator, so I'm not going to do it. So that's the idea here, that we're going to do everything we're going to get is going to be placed in the unit circle to make all of our lives easier. Okay. Wow, it was weird that you guys didn't really need me. I guess you can. All right. Well, why don't you pass that one up then too? We'll keep on going with this trig and all this homework. But it's not like it matters. You do it, it doesn't change anything. Right? You'd be surprised at how much it has no bearing on anything. What's up? That's fine. Yeah, it makes sense. I figured I'm not really. And that's the idea. It really is free. Excuse me. So, I guess it kind of moves everything up then. I honestly didn't expect. I mean, not to say that it still kind of goes off the idea of working backwards from before. For example, if I wanted to know, when you guys did this with calculators, if you had the sine of something equaled 3/5 and you needed to figure out what theta was, what buttons did you press on the calculator? Inverse sine. So you'd say that theta equaled inverse sine of the fraction 3/5, and you got some crummy decimal. Okay. Now, what we're going to do with this is that we're going to figure out what angle has a sine value that equals 1/2. What angle has a sine value that is -√2/2. Things like that by working backwards out of the trig functions. But what happens here is, instead of going into the entire whole circle, there's going to be certain parameters for which you're going to look for the values of theta. And that's where things get a little messy if you're not careful. For example, excuse me, sine values. When we're trying to figure out what value of sine that we're going to look for, what we're going to do is that we're going to search for values of sine between pi/2 and -pi/2. Yeah. As we get into this, you'll see why this happens. By looking at your values of, if you think about it, sine's always positive between 0 and pi. It's positive in the first two quadrants. By looking at it this way, you're going to figure out all your negative values of sine in the fourth quadrant and all your positive values of sine in the first quadrant. That's why they bounce back and forth like that. Excuse me. This becomes really simple when we start doing some examples. When we look at cosine, when we're searching for cosine values, we're going to search for cosine values between 0 and pi, because cosine goes negative in the second quadrant. Oh, man. Ugh. So when you're looking at cosine, cosine will go between 0 and pi. And like I was saying, as we get into this, it's super easy to see where this is all going to go. It's just a matter of placing what value it is and working out of it. And then, what's that? And then, yeah, the tangent is the weird ball. Now remember, the tangent at pi over 2 was undefined. Remember how we did that? Because it was y over x, and then you have 0 in your denominator, and all things were bad. And you remember how we kind of showed you guys, or I showed you a while ago, when you're working with these, how the graphs look over time? When you're dealing with tangent values, your tangent values have those asymptotes. And I think we looked at this before. If you think about what's happening with tangent, as you go through your 4 points around, you're at 1, 0, 0, 1, -1, 0, and then 0, -1. Those are all your points on the quadrantals. We're okay with that? Now, if you looked at it graphically, at 0, tangent is 0 because it's y over x, 0 over 1. At pi over 2, tangent would be undefined because there's an asymptote, because it's 1 over 0. Same thing at negative pi over 2. The weirdness happens here. When you're at 45 degrees, what's tangent at 45? 1, because it's the same value. Okay? So at 45, in terms of pi, would be pi over 4. And then at negative pi over 4, it's at -1. So its tangent graph does this. Okay. The tangent graph does that. It is not, bless you, it's not a continuous function because, bless you, because it's got those asymptotes. So when we're searching for values of tangent, we're going to search for them, this out of the way real quick. We're going to search for them between pi over 2 and negative pi over 2, not including them. Those open dots reference the fact that we're not including them, just like we've done before with graphs where they're not equal to versus equal to. Okay. Excuse me. And it's just a matter of how these things get placed into the quadrants. For example, we okay on that one? So remember, you got sine between between pi over 2 and negative pi over 2. Bless you. And that's where we're going to place them, and then we just work our ways out. So it was the same thing we had. But tangent, we don't include pi over 2 because it's got an asymptote, because you can't divide by 0. Whereas sine, you can include it because the sine at pi over 2 was 1. Tangent's the weird part. Excuse me. So, for example, if I want to look at it, if I want to go real basic, and I ask this question: what angle has a sine of root 3 over 2? So, when we're thinking about it, root 3 over 2, is that going to be in first or fourth quadrant for sine? First, because it's positive. So you start going into it. When you place theta, remember, you're placing theta at the origin. Your opposite is the root 3. Your radius, your radius is the 2. Which angle has the opposite of root 3? 60. So what angle has a sine of root 3 over 2? 60 degrees. But we don't say 60 degrees, we say pi over 3. Because it's radians. We're not using calculators, we use radians. It depends on how they were given. We'll get into that. We'll get going. Right? What you were doing before, you were getting all your answers going to be in root 2s and root 3s and stuff like that. Now we're working out of that. Now we're going backwards. All right, so it's pi over 3 or 60 degrees, depending on what it asks you. Sometimes it might ask you for give your answer in radians, give your answers in degrees, or it might say give your answers in both radians and degrees.
Why is it in the first quadrant here if it's also in the house?
It's a duplicate angle. What happens is you start thinking about it, when you have positive in the second quadrant, you're correct because these values here are the same. Yep. And that's where reference angles come from. So this is the case where you don't have to look, when you're looking for just one angle, you're searching for one spot. Later on, when we get to solve equations, we're going to find every value of theta within one revolution that will have that value of sine. And then you're right, then you would have first quadrant, second quadrant to deal with. But we're not there yet. But thank you for reminding me that we will get there. Okay. It's a good question. All right. Let's think of another one. What about this? What angle has a cosine of 2? What angle has a cosine of 2? What's that? Correct. Why? Right. Can you have any? Remember, the values of cosine, or values of sine and cosine, are always less than or equal to 1, or greater than or equal to -1. The answer here is no. You can't. You can't have a cosine. You can't have an angle that has a cosine that's larger than 1. So you say no, or you can say it's undefined. That doesn't work. Can you have that with tangent, though? Yeah, you can have that with tangent because remember, as you start getting into this more and more visually, remember how when we graphed sine and cosine, and you guys all went, ugh. And I just kind of quickly showed how it's going to go. Sine went 0, pi over 2, 0, negative 3 pi over 2, 0. It did, whoa. Sorry. It did that for sine, and then cosine started up top. And it never got larger than 1, and never got smaller than -1. And that's the idea here. those things won't happen. Whereas in tangent, at tangent you have these asymptotes. What do you mean? We use this all the time for everything in trig. Any trig value stuff that you will see from here on out. Trig is like the most common thing used in all math. Seriously, it is. Trig is one of the most commonly used maths.
I love Common Core.
This isn't Common Core.
It's still based around the concept of taking everything.
No, trig is the most basic algebra 2 concept that you come across. It's a building block going into all three columns. It's one of those things. Tangent, this one, blah, blah, blah. We did that. All right, where is tangent -1? What angle has a tangent of -1? You're right. There's actually more than one of them, but for when we're searching for a singular angle, we're only looking for it in one spot. You're saying it. You're about to say it. Yeah, but where? Remember, when you're dealing with tangent, you're looking for tangent values between pi/2 and -pi/2. Okay? So where is tangent going to be negative? In the first, in this quadrant, or this quadrant? The top or bottom? The bottom. So that means that we have a tangent value down here. Theta had to be placed in order to be -1. Remember, that has to be what angle? It's got to be a 45. But in this case, it's got to be a -45 because it's between, remember, it's going between 45 degrees, 90 degrees and -90 degrees. So it has to be -45 or -pi/4. You're just placing it to figure out where it goes and what angle created that. And your angles have to for each of these values, they have to be within a certain parameter. Sine has to be between pi/2 and -pi/2. Cosine is between 0 and pi. And tangent would be pi/2 not inclusive and -pi/2 not inclusive. And that's all we're placing. Placing it and seeing where they land. Okay. Excuse me. All right. Do those four. I don't want to. So tangent, positive tangent is going to go into the first quadrant. And for it to be tangent, you're looking at opposite √3, your adjacent has to be 1. Which angle has an opposite of √3? 60. So your answer here would be 60 or pi/3. Okay. Cosine √2/2. For it to be a √2/2 and it's positive, your first quadrant again. So your adjacent hypotenuse. Excuse me. Now, isn't that probably one that's been rationalized? √2/2 is a rationalized one, isn't it? So it's not going to be this clean like that. That was your 1/(2), wasn't it? To get √2/2 was a rationalized value, which means it had to have been what angle? 45. They're going to trick you with those rationalized values. So you have to try to think of it sometimes, okay, wait a second. That's probably been rationalized when you see a root in the numerator like that. When you have the same thing, like √3/3, it's been rationalized. √2/2 has been rationalized. Sine, 1/2. What quadrant does that go to? First one again. So there's your 1 and 2, which makes that a what degree angle? 30. It's going to be a 30. Or pi/6 And then lastly, when you're looking at cosine being negative, that puts you to the second quadrant,
Are you sure?
negative 1. 60. Now that's 60 in that quadrant here. This is a 60-degree reference angle, but that means your angle is this, which makes it 120. And then in terms of radians, it's pi over 3 up, which means it is 2 pi over 3. Cosines, when cosines go negative, that means it's going to be an obtuse angle. Anytime you're trying to find an angle that has a cosine that's negative, your angle is going to be obtuse because it goes to second quadrant. Sines and tangents will not have any obtuse angles. They're just going to have negative angles. Okay. I'll post this out here in a second. Just 8 of them, okay? 8 of those types of problems with radians and degrees, please. Radians and degrees.